Hi, ladies and gentlemen. I wanted to go through and give you a little tutorial on how to do the element cards assignment if you were not present or you're working on it at home. So first of all, in the element cards, you're going to go to card number 2. Okay, we're starting there, and I want you to start on the left-hand side. On the left-hand side, you're going to go through, and step 1 is to figure out how many protons, how many neutrons, and how many electrons are in this element. Okay, so how do I figure that out? Okay, if you remember, the number of protons is equal to the atomic number. So number of protons is equal to the atomic number, so that's going to be 5 for boron. Okay, the number of protons in a neutral atom is also equal to the number of electrons. So the number of electrons is also 5. And then we have to find the number of neutrons. To find the number of neutrons, you take the atomic mass, which in this case is 11, and you subtract the atomic number. So you're taking the larger number and subtracting the smaller number. So 11 minus 5, that gives me 6 neutrons. Okay, so that's part 1, is completing the number of protons, number of neutrons, and number of electrons for each element. Okay, we'll go through, I'll show you guys for lithium, but like I said, I want you to work on the left-hand side of your page to start off with. Okay, so for lithium, okay, number of protons is the atomic number, so that would be 3. Okay, the number of protons equals the number of electrons. Okay, so that means electrons is also, those are also 3. And then neutrons are the atomic mass, which in this case is 7, the larger number minus the smaller. Atomic mass minus atomic number gives you the number of neutrons, so 7 minus 3 equals, click on there, 4. Okay, so you're going to go ahead and find the number of protons, neutrons, and electrons for all of the element cards on the left-hand side. Okay, so go through and do neon, then carbon, then sulfur, hydrogen, okay, all those ones on the left-hand side. So what you should do at this point is pause the video, get the number of protons, neutrons, and electrons for each of those completed. Okay, once you have that completed, then you're going to come back and we'll work on part 2. Okay, so pause your video now, find the number of protons, neutrons, and electrons for each of your elements. Okay, so once you come back, okay, we're going to start on part 2. Okay, part 2 has to do with the number of electrons in each shell. Okay, so if you remember, Bohr came up with the idea that electrons travel in circular orbits. We have since then figured out that their orbits aren't necessarily circular, but they are going to be within a particular shell or a particular distance from the nucleus. Okay, and so we're showing that shell down here with these rings. Okay, and when we talk about the rings or the shells get full when we have too many electrons. And so the first shell can only hold 2 electrons. The second shell can hold 8. The third shell can hold 18, and we won't go beyond that, but the next shell would hold 32. Okay, so what you're going to do then is you're going to place electrons in starting with the inner shell and then moving your way out into each of these layers. Okay, I don't have, normally there's a little electron there. If you didn't get one, come over and grab it from lithium. Okay, and I'm going to copy that electron and I'm going to place it, okay, in the first shell. Okay, boron has 5 electrons, so I have 2 electrons. Remember, that's the max for the first shell. 2 electrons in the first shell, and then, okay, I need 3 more. Okay, so the 3 more are going to be in the outer shell. Okay, so I've got a second one, okay, and a third one. So now I have electrons in every shell. Okay, so 2 on the inner, 3 in the outer. All right, so for boron, boron has 1, 2, 3 valence electrons. 3 electrons in the outer shell, and then 2 electrons in the inner shell. The electrons on the outer shell are what are going to be important in terms of making bonds or combining with other atoms. Okay, so that's really the goal, is for us to figure out how many valence electrons are there. Okay, so once you complete boron, then you're going to move to neon. Okay, neon has 10 electrons. Okay, so you're going to take your electrons, okay, and place 2 electrons in the inner shell. So copy and paste them, and then 8 electrons in the outer shell. And it doesn't matter exactly where you place them. I kind of spread them out around sort of evenly. Okay, just remember they're not necessarily traveling in that circle. So the idea is just that they're that distance away from the nucleus. Okay, so there'll be 2 electrons in the inner shell, 8 electrons in the outer shell, and that'll give you a total of 10 electrons. Okay, then you'll move on to the next slide. Again, you're filling in inner shell first. Okay, inner shell can hold a maximum of 2. Once you get to 2, then the rest would fill in the outermost shell here. Okay, and then you see over here on the right-hand side, phosphorus. There are 1, 2, 3 shells. Okay, so phosphorus must have more than 10 electrons. If it has more than 10 electrons, then you're going to move into the third shell. Okay, and the reason why it's once it goes over 10 is because the first shell holds 2, the second shell holds 8. So that gives us a total of 10 in the first 2 shells, and anything over 10 would then be in the third. Okay, so you'll do that. Sulfur is another example. This has 3 shells. Okay, so you'll have electrons in the first shell, the second shell, and into the third as well. All right, so you'll complete those electron configurations, or where we find the electrons for each of our cards. Again, please start on the left-hand side. Okay. Once you have done that for all of your cards, okay, why don't you pause the video now? Okay, you can complete that for all your cards, and then we'll come back and we'll do the last part of the lab. All right, so complete those electron configurations for each of your elements, okay, and then we'll move on to the last part. All right. All right, now that you have finished, okay, and you have the electron configurations for all of your elements on the left-hand side, now we are going to complete what are called electron dot diagrams. Electron dot diagrams tell us about the valence electrons in the atom only, okay, valence electrons only. Okay, and again, the reason why we're concerned about the valence electrons is because the valence electrons are going to tell us how many bonds that atom can and wants to form with other atoms. So it essentially will tell us kind of how many reactions or how many links it wants to form with other atoms. Okay, so for boron, boron has 1, 2, 3 valence electrons. So remember, valence electrons are the outermost shell. So what I'm going to do is I'm going to start at the top above my symbol. Okay, I'm going to click on one of the open circles, okay, that's above. Okay, and then I'm going to move to the side and click on one of the open circles that's on the side, and then I'm going to click on one of the open circles that's on the bottom of the symbol. Okay, so now I have all 3 of those open circles selected. I'm going to fill them in, so pick a fill color. Okay, and once I have them filled in, okay, then I'm finished. Okay, and what I see here is that boron has 3 valence electrons, and those 3 valence electrons are unpaired. So the 2 that are above the symbol, the 2 that are on the side, the 2 that are on the bottom, and the 2 that are on the other side, those are paired electrons. Okay, and so we start off, and the electrons initially are going to be unpaired. Okay, so that's why I put 1 here, 1 on the other side, and 1 on the bottom. I didn't do 2 on the top and 1 on the side. Okay, it's because they'll start off being unpaired. This means that boron wants to form 1, 2, 3 bonds with other atoms. And then when it forms those 3 bonds, that will allow these electrons to become paired. Okay? And that makes atoms happy when they have paired electrons, paired valence electrons. Okay, once you've completed that for boron, you're going to do it for the rest of the elements on the left-hand side. Okay, lithium. Okay, if I look at lithium, it has 3 electrons. Okay, there would be 2 in the innermost shell, 1 in the outermost shell. That means that I would just take one of these, okay, and I would fill in one of those open circles. okay? So I would highly encourage you, like now that I have boron built and these electrons built, I'm going to take these and I'm going to hit shift and I'm going to hold shift down and I am going to copy, control C, copy all of those electrons. Okay, if you are building these shells, okay, so then when you move to the next one, okay, you could paste all of those electrons in and then just add on from there. Anyhow, that's just a tip for speeding up building the electron configurations. Okay, again, I think it helps to select all of these, okay, these open circles. So depending on how many valence, remember it's just the outermost shell, it's not the combined inner and outer shell, it's just the outside shell that you're looking at, how many electrons there are. Neon, it happens to be 8. So all of those open circles are going to be filled in. And I'm using this fill color tool that's at the top. You might have to go over to more, okay, to find that tool if it's not showing up for you. Once you've completed that for all of the elements on the left-hand side, you can come back and do the right-hand side for extra credit. Okay, so if you're interested in completing the right-hand side, that would be extra credit for you. All right, ladies and gentlemen, I hope that helps. Let me know if you have any questions. Okay, and I would encourage you to go back, rewind the video if there's something that you missed. Okay, don't forget the key ideas are that protons are that equals the atomic number. Neutrons are the atomic mass minus the atomic number. The electrons will equal the number of protons. Okay, when we fill in our shells hold 2 and then 8 and then 18 electrons. And then when we create our electron dot diagrams, we are only concerned with the outermost shell. Okay, that outermost shell, those are called valence electrons. And for each valence electron, we'll fill in one open circle. Okay, and once we've filled in one on each side, then we can start pairing valence electrons. So if we have over 4 electrons, then we would see these open circles next to each other. They could be filled in. All right, ladies and gentlemen, I hope that helps, and let me know if you have any questions.